Hello everybody and welcome to a video on choosing random numbers. In this video we'll talk about basically two things: how to generate random numbers and then what can you do with that. So essentially, if you want to do any sort of programming that involves chance, so think about a dice rolling game, you want to write a Monopoly program or something, then you have to be able to simulate random processes like rolling dice. So rolling dice, rolling a single die, I guess, is equivalent to generating a random number in a given range. In the case of a die, you're talking about a random number between 1 and 6. So we'll talk about that. How do you generate a random number where you want it to be? And then I'll show you a few examples of using these things. So how do you generate a random number? Well, it's pretty straightforward. You use this thing called rand, empty parentheses. That generates a random number between 0 and 32,000. And so let me just show you that. So I'm just going to say cout rand, okay? So all that's going to happen when I run this code is it's going to print a random number to the screen. So 16807 is the random number that it has generated. Now let me run this program again. Notice it prints out the exact same number. Like every time I'm running this program, it gives me the same number. So that's bad. Okay, so if you actually want to simulate dice throwing, then presumably when you run the program again, you want the possibility of having different numbers rolled. So the rand function will sort of generate a random number for you, but this is actually kind of a lie. Okay, so sorry, I don't like to usually start videos with a lie, but I did this time. So what really happens here is the rand function picks off a number from a built-in random number table. So the computer has a random number table already inside of it, and what the function does is it just goes in there and picks a spot and tells you what number is there. And unfortunately, this function will look at the same place in this random number table every time you run the program. So unless you tell this function, hey, I want you to look different places, please, when you run the program, it's just always going to go to the same spot in the random number table, and therefore it will always give you the same, quote, randomly chosen number, end quote. So how do you fix that? Well, to mimic actual randomness, the function should go to a different spot in the table every time it's used. This is called seeding the randomness. And here's how it works. You use what's called the srand function. S stands for seeding, so seeding randomness function. This starts reading the list at the seed position specified by the number I put in here. So srand 10 starts reading at position 10 inside of the random number table, for example. And ideally, every single time you run the program, you should change where you're looking. An easy way to do this is to use the current time as a way to get a different number. So we're going to use a command called time null, and this gives the number of seconds since January 1st, 1970, and I forget the significance of this date. It was like the invention of the personal computer or something like that. But anyway, this time null is an integer that changes over time. Right? That's why we're going to use it. So every single time we run the rand function, this guy, we're going to seed our randomness using this number of seconds since January 1st, 1970. And that way, every time we run the code, we're looking at different spots inside the random number table, and therefore we will have something that's mimicking true randomness. So to use that seeding randomness command, you just go srand time null. So you're telling the thing, look, start looking in the random number table at this spot, this number of seconds since 1970. And if you want to use that command, you have to use include ctime up here. So you have to add another library include command up here. But now when I run this, notice these numbers here. So only focus on the last 5 digits or so. Sometimes these first 5 digits don't change. So watch now. Notice the last 5 digits are changing over time. Okay, so you are getting different numbers every time you run the code. So now we're getting something, as long as you only focus on the last 5 digits, you're getting something that mimics true randomness. So if we're going to model dice throwing or something, then now every time we run the program, the dice may roll something different. Okay, they're not guaranteed to roll the same thing. Okay, so let's think about a few different questions here. How do you generate a random number between two given values, between 5 and 17, in the case of a die, in the case of the case of a die between 1 and 6, etc. So let's start with a very specific value for A and a specific value for B. How do you generate something random between 0 and 9? Well, 0 through 9 represents all possible remainders when you divide by 10. Okay, so if I hand you any whole number and say, hey, before you even divide this, tell me the possible remainders I could get when I divide by 10. You would say, well, either you have 0 remainder, in which case you have a multiple of 10 already, and the other options are 1 through 9. So it all depends on the last digit in the case of dividing by 10, right? If your last digit is a 0, then you're a multiple of 10 and there's no remainder. If your last digit is a 5, then your remainder is 5 when dividing by 10, etc. Okay. But anyway, the point is that when you divide by 10, there are only 10 possible numbers you could get. And those numbers are the numbers between 0 and 9. So here's a command that will generate a random number between 0 and 9. Generate a random number for me, please, and then divide that number by 10 and take its remainder. Okay, so again, no matter what this number is that I just generated, if I divide it by 10, there are only 10 possible options for the remainder, and those options are 0 through 9. So let's come back up here, and now I'll say, hey, generate a random number for me, but then divide it by 10 and take its remainder. 6. Okay, there you go. So just to be clear here, let's let int x be rand, and then we'll cout x, and then cout x percentage 10, just so you can see the original number it generates and then the corresponding random number. Okay, so the random number it generated was that. That's x. But then you said take x, divide by 10, get the remainder. So 5 is the remainder when you take this guy and divide by 10. Okay, so that's how you can generate a random number between 0 through 9. Well, what if you want to generate a random number between 1 and 10? Well, we know how to generate random numbers between 1 and 9 now, so all you got to do is take those 10 options and shift them up by 1. Okay, so here is a random number between 1 and 10 now. You took your possible options between 0 and 9 and just did plus 1 on them. So let me just show you that. X now, let me just get rid of this. So let's now do 1 plus rand percentage 10. So again, rand percentage 10, that little chunk can be anything between 0 and 9. So 1 plus that is anything between 1 and 10. There you go, 6 again, 3, 10. Okay, so before we couldn't get a 10, but now we can get a 10. And now we could get a 0 before, but we can't get one now, etc. Okay, well, what about a random number between 12 and 21? Well, again, like what's special about the 0 to 9, 1 to 10 examples? What's special is that you're generating from 10 numbers in a row. Okay, so 1 through 10, that's 10 consecutive numbers. 0 through 9, that's 10 consecutive numbers. Well, 12 through 21 is also 10 consecutive numbers, so we can just mimic exactly what we did here. It's just now we want to take our 0 through 9 options and shift them up by 12. So with 1 through 10, we took our 0 through 9 options and shifted them up by 1. Well, now we want 10 numbers from which to choose, but we want to start at 12. So let's just take this here, put a 12 right there, and go. So 15, 19, 13, 20. Okay, notice all of these numbers are in the acceptable range, etc. Okay, so I should mention here that typically the mistake students make, if they remember this sort of syntax here, the mistake they make with this is they know that like 12 and 21 are somehow involved in what you write right here. Okay, so the typical mistake that people make is they would say, well, I know I want to start at 12, and then I'm supposed to end at 21, so I'll put a 21 right there. But now if I run this, so I got a 21, 14, going 14, yeah, 28, okay? So what's happening here is this represents any possible remainder when you divide by 21. Well, those possible remainders are 0 through 20. Okay, so when you divide by 21, what's left over can be anything from 0 up to 20. So what you're doing here is you're taking 12 and adding any possible number between 0 and 20. So you can get all the way up to 32 here. But that's not what you want. You want to stop at 21. So this number here, after the percentage symbol, that's the amount of numbers from which you are choosing. Okay? So this first number is always the start number. This number is the number of numbers that you can choose from. So you're actually choosing from a range of 12 plus this number minus 1. So you're starting at 12 and going up to 10 minus 1, which is 9 more. So this does represent starting at 12, ending at 21. Okay. And so on. So that's all with 10. So if you want to generate a random number from 10 consecutive numbers, starting with the number A, this is what you can do. Okay. So there's nothing special about 10. If you want to generate a random number between 0 and 4, well, 0 through 4, that represents the set of possible remainders when you divide by 5. What if you want to generate a random number between 11 and 16? Well, these are 5 numbers. This is a range of 5 numbers, right? 11, 12, 13, 14, 15, 16. Whoop. This should say 15. Oh, well. But anyway, so you have 5 numbers here. You're supposed to have a range of 5 numbers here. So if you can do this, then all you got to do is shift that up by 11, just like we did before. So here is a random number between 11 and 15. Sorry. So it shouldn't say 16, it should say 15. Whoops. So we're starting at 11. And notice these numbers are between 11 and 15. So we are starting at 11, and we're adding anything between 0 and 4 to that. So we can start at 11 and go all the way up to 15 if we want. Okay. So what's the punchline of all of this? The same logic extends to choosing a random number between any place and any other place. If you want to generate a random number starting at A and ending at B, here is the line of code that will do that. You start with A, and then you add the possible remainders when you divide by B minus A plus 1. So just like back up here, yeah, between 1 and 10, here's A, here's B. So we start at 1, and then we have to do B minus A plus 1, so 10 minus 1 plus 1, which is indeed a 10. And then back here, yeah, so 11 and 15, so this is now 15 minus 11 is 4 plus 1, that puts a 5 right there, okay? So this is the line of code you should know if you ever want to generate a random number between A and B, so from a range of values. So just for example here, if you know this, now if you want to generate a random number between 11 and 35, you know you start at 11, so 11 goes right there, plus randomly chosen number when I do 35 minus 11, which is what, 24, and then plus 1 gives me a 25 right there. Okay, so let's just do some stuff with this. Let's first of all simulate 2 dice rolls where I roll the dice 10 times. So simulating a dice roll means choosing a random number between 1 and 6. So if you want to do between 1 and 6, that means you start at 1. And then what number goes right here? You take your end number minus your start number, so 6 minus 1 is 5, and then add 1, and that gets you right back to 6. So here I've randomly rolled, like I've just rolled dice 1 essentially, right? I've chosen a random number between 1 and 6 to put in dice 1. I'm supposed to do 2 dice, so let me give you another one. So, oops. 1 plus, and then percentage 6. And then let's just output those two. Oops. And let's see what it does. So it rolled a 5 and a 3, and next time it rolls a 1 and a 5, etc. Okay. So now the question is, I want to do this 10 times. So it seems to me the most natural thing to do is set up a for loop. Start at 1, go up to 10, I++, and just every pass through the loop, we will roll the 2 dice. And what does rolling a dice mean? It means just choosing a new random number for that value. So here I've just rolled dice 1. And here I will roll dice 2. So this loop will run 10 times. Every single pass through the loop, I roll dice 1 by choosing a random number. I roll dice 2, and then I print the result to the screen. So let's see what that looks like. Okay, oops, I should have. That looks terrible. I should put a new line at the end of each pass through the loop so we can read it. Okay. So 5, 6 on the first pass through, 5, 2 on the next pass through, 5, 5, etc. Okay. So if you want to roll 2 dice like thousands of times, all you have to do is adjust this in the for loop. So that's how you can simulate rolling 2 dice, simulating different numbers. Oh yeah, okay, so let's talk about generating different random numbers. And in particular, in particular here, if I want to generate just a single random number between 1 and 10, that code looks like, and let me just get my 3 variables going. That code looks like x equals 1 plus rand percentage 10. Okay, so I've sort of rolled a 10-sided die here. X is now a random number between 1 and 10. So y, I also want to be a random number between 1 and 10, but y is supposed to be different from x. I want to generate different random numbers, okay? So once I've chosen y, let me just write a loop that says, hey man, as long as x is y, please roll that die again for me. So in other words, let's say x is 7 after this roll right here. Then after this line of code, y could also be 7. So they're both 7, so I'd go in here, and now I will roll the die again. And it's possible for y to be 7 again. You know, it's possible to get 2 7s in a row. So if that's the case, that's fine. Now I come right here, and then x is still y, because y is still 7, and then I just roll the die again. So let me just come down here, x, y, 1 and 6, 5 and 4, 9 and 2. Okay, no matter how many times you run this, those two numbers will be different because this loop is forcing them to be different. Okay, now I want to roll z, and oops, z equals 1 plus rand percentage 10 also, but now I want to make sure that z is not x or y. Okay, so z has to be different from x or y. So let me just now say right here, as long as z equals x or z equals y, then I need to roll the die again. So here's how you can generate numbers that are different. So x, it doesn't matter what it is. Okay, you can let it be whatever. But now when you choose y, you want to make sure that y isn't x. So as long as y is x, then just choose a different value for y. And down here, you can choose a value for z, but as long as z is the same as x or z is the same as y, please choose a different number for me. So now if I run this code, just print all three of them. Oops. Failed. What is happening here? Oh, I forgot to close my loop. Okay. Okay, 3, 6, 2, 1, 5, 3, 5, 3, 2, etc. Okay, these numbers will always be different. And these two little loops right here ensure that they are different. Okay. Yeah, so let me just finish by mentioning that you can, of course, use random numbers to code for other things. So if you think about simulating like dealing of cards, okay, well, a card you can think of as being a number between 1 and 52 if you want, right? So you can just assign 1 to be the ace of hearts, 2 to be the the 2 of hearts, 3 to be the 3 of hearts, etc., all the way up until 13 is the king of hearts, and then 14 could now represent the ace of diamonds, 15 the 2 of diamonds, etc. Or you could do what we just did with the dice and just have two separate numbers keeping track of two separate things. So you could generate a random number between 1 and 4 to represent a suit, and between 1 and 13 to represent the value of the card. So you generate like 2, 7, and maybe that 2 means diamonds and the 7 means 7, you know. So a 2, 7 means you just generated a 7 of diamonds, or whatever. Okay, so you can use random number simulations and like dice rolling to simulate all sorts of other things. In particular, let me just close by showing you this example. Where is it? Okay. So this is a program that I use if I want to randomly generate 2 Calc 1 students. Let me just put this in here. So I have, let's see, how many students? I have 20 Calc 1 students. And if I want to randomly generate 2 of them because I want them to work in a pair at the board or something, you know, so I'll say, look, I need 2 of you to come up to the board and work this out, right? Well, if I want to be fair about it and I want the choice to be random, then I can let x be a number between 1 and 20 that represents 1 student, and y be another number between 1 and 20 that represents another student. But of course, I don't want to choose the same student. So if it's possible that x is 15 and y is 15. So to avoid that, I have the same sort of loop as I had a second ago that forces you to get 2 different values. And then each student has a number. So if x is 1, then Megan comes up. If x is 2, Courtney, etc. And then down here, if y is 1, Megan comes up again, etc. Right? But this loop has ensured that x and y are different. So here's what the code looks like overall. So I choose 2 random numbers. I make sure they are different. And then once they are different, based on what they are, I choose 2 different students. So if x is whatever, a student comes up. And then if y is whatever, a student comes up. So if I run this, Luke and Rhett will come to the board. Carson and Rhett will come to the board, etc. Okay? The 2 students here will always be different because right up here I have ensured that the 2 numbers are different. But all of this to say, you can use random number generating to simulate all sorts of other processes, not just dice rolling, but card dealing, person choosing, etc. Okay? You just have to encode your choice as a number, as I've done here. Okay, so that's the end of this intro to random numbers. Oh, and I'll put that code on Moodle if you want, that student chooser. So at the end of this video, you should be comfortable with generating random numbers between 2 values and using that sort of code to do things like simulate dice rolling, card dealing, etc.